Hello, welcome to the video on Cramer's rule. This is our third example set C. And before we get going here, it's really important that you have watched the lesson and have also done the other previous example set, the other worksheets, example set A and B. Okay. All right. So as we just have been discussing, that Cramer's rule is a way to solve linear systems. All right. So far we've been doing 2x2 systems, but you can also apply Cramer's rule to solve 3x3s, i.e. 3 variables. Okay. The key here is that you need to know how to calculate the determinant of a 3x3 matrix. All right. So if you don't know how to do that, you need to go back and review how to do that. There's basically two ways, and that's going to be the diagonal method and the expanding method. So let's go ahead and start. So the first thing you do, there's so many calculations here. I've kind of already pre-done it in this video, but you should be able to, get the exact same answers as I am. If not, you're having trouble, probably trouble calculating the determinants of these 3x3. So the first thing we need to do is we calculate the determinant using the coefficients of the variables. Okay, now you notice we have x, y, and z. Everything is lined up in its proper column. So here we have -1, -2, 1. So you can see that's our first column. We have 4, 1, -1. That's our second row. Here we have 2, -3, -1. And it's our last row. So this sets up our first determinant. This is going to be our denominator determinant. So we only have to calculate this once. All right. So when you see here, I'm actually using the diagonal method. You see how I set it up. And I don't want to get into it because this is this is a lesson in and of itself. But I'm using the diagonal method. You can use the expanding by minors method if you like. I just find the diagonal method much easier. When everything's said and done, I get -14 as my answer. Okay, so let's go ahead and keep that in mind at -14. Let's move down. Now here, just as we did with the 2x2 systems, okay, when we want to solve for a particular variable, what we need to do is replace that variable's coefficients with the constants here. Okay, this is why it's really important that you understand how to use Cramer's rule with 2x2 systems. So let's go ahead and replace this -1, 4, and 2. We're going to replace it with 7, -21, and -7. So you can see how that's all set up. And then the rest of our coefficients are the same. The y's haven't changed, and neither have the z's. All right. So -14 is our denominator determinant, and we already figured that out. Okay. So we're going to keep that throughout the rest of this procedure. So why don't you take a moment and calculate the determinant of the numerator here. Okay. I have the answer below, but it's really important that you know how to do that. So, give yourself some time. These sometimes take a good 5 minutes to do, and it's nice if you have a calculator to help you through these calculations. Okay, so let's go ahead and see what I got. Here it is. I set it up using the diagonal method. You can see my work, and when everything's said and done, I got a +70. All right, so we're solving for x. So that numerator determinant was a +70. Our denominator was already -14. That was our first determinant we calculated. So 70 divided by -14 is -5. So far we have x is equal to -5. All right. So hopefully you're getting the hang of this. Let's go on and set this up for y. Okay, you see here I've already set this particular determinant up. I replaced the y column, that's -2, 1, -3. Notice I replaced it with the constants. All right. So here the x's are the same and the z's are the same. Start at -14. Let's go ahead and see if you can calculate the determinant. And if you can calculate the determinant, there's absolutely no reason why you can't get the correct answer. All right. So give yourself time. This particular problem here, it would probably take, I would say, probably a good 10 minutes to do without rushing it. So no reason to, but go so fast you're going to make errors. Okay, so once again, check your work here. I got a positive 14, and here, once again, I did this by using a diagonal method of finding these 3x3 determinants. So you can see here, you can pause the video and you can review what I did here, or go back and watch the lesson on 3x3s. But you should have got a positive 14, and you can see here now that the determinant is a positive 14. I'm going to divide it by that negative 14 that we found out that was our very first determinant. So 14 divided by negative 14 is negative 1. Alright, so y now is equal to negative 1. So all we need to do is solve for z, and we're going to do it the exact same way. Now why don't you take a moment before I actually show you how to set it up. Let's see if you can do it yourself. Alright, so go ahead and write that out for z. Okay, so here it is. You're going to replace the z numbers, the z coefficients, with 7, negative 21, and negative 7. So it looks like that. Okay, that's what you should have set up. And if you did, good job. Now what you need to do is go ahead and follow through and calculate that determinant. You may want to pause the video, see if you get it right. Okay, so once again, the diagonal method, and everything's said and done, you get a 0. So it's going to be 0 divided by negative 14, which of course is going to be 0. It's really easy. So z is equal to 0. Alright, so our solution set, recall, our first one was negative 5, which was x is equal to negative 5. We had y equal to negative 1, and we had z equal to 0. So we write it as an ordered triple. Okay, and there you go. Alright, so Cramer's rule is an excellent way to solve any linear system. It's just another tool. Some of you might want to use row operations or linear combination, substitution method, but it's another tool, and some of you may really like this. Now you have even a better way to solve these systems. Once again, if you made some mistakes here, two things. One, chances are you need to go back and practice your determinants, calculating determinants. Or two, you're making some sort of arithmetic or common little, we like to call them like silly mistakes, or adding things wrong. And that just goes with experience. Write neater and take your time. Okay? All right, so good luck to you, and hope to see you soon.